We're going to talk about the future of the IDE in the next 25 minutes. And with that, let's just dive right in. I thought before we would go deeply into the future, what we would do is we would first look at the past, take a look at the past 40 years of developer tools. On the left over here, I've got a punch card. And in 1970, we have the innovation of text formatting, also known as pretty print. After that comes the first IDE in 1975. For the first time, you're able to compile and debug, put that all together in one environment. After that, you've got code folding innovations coming in. Static code analysis comes in 1979. In 1982, you have multi-undo and brace matching. If you were a developer back then, you might remember advertisements for products that say up to 8 levels of undo with exclamation marks right after them. People were very excited about that. After brace matching and undo, you have syntax highlighting, probably one of the most significant advances in our history, happening in 1985. After that, plugins, the first IDE was supporting plugins came up in 1989. In 1991, you have drag and drop form design in Visual Basic. In 1993, you have markers and templates, which are the precursor. Templates are the precursor to code snippets, and markers are navigation tool for finding your way through the code. In 1994, you have Smalltalk's refactoring browser comes up, and in 1996, you have IntelliSense, another great innovation. In 1997, you have consume first declaration, where you write the consumption code first, and then you can declare the missing pieces to make everything compile. In 1999, you have declaration view. That's the precursor to Visual Studio's code definition window, where you put the cursor on some code, and then you get to see something in the background. For example, a class hierarchy diagram, or some code behind you so you can see what code is behind the method that you're on. Background error checking came in 2002. And in 2005, you have modeless refactoring and preview hinting. So modeless refactoring doesn't throw up any modal dialogues, allows you to refactor, and then preview hinting shows you what's going to happen before you do it. This is in 2005. Later on, Office took these same innovations, and you see them throughout Office. In 2007, you have a feature called tab to next reference, which is essentially like being able to do a find all references very quickly. And doing that by simply hitting the tab key. And after that, you have structural search and replace, which allows you to search for a particular structure and replace it. That's 40 years of development. That's my pick of what I think are the most significant advancements in the last 40 years. Now, if we take a look at this, we'll look at one other thing that's happening over this time, and we're looking at quality, efficiency, and sophistication of the application as we're moving forward in time. And what's happening is they're all increasing. The quality of the code is increasing, the efficiency at which the developer's writing the code is increasing, and the sophistication as well. Notice around here in 1985, we see the big jumps in these right here. And again, over here, we have jumps in quality when we have background error checking, things like that. So these things are happening. These are the trends, right? So if we look forward 40 years, we kind of expect these trends to continue, right? We'll be more efficient, the quality of our code will improve, and the sophistication or complexity of the code that we manage will increase as well. But we'll be able to manage that with the same amount of effort that we're currently using today. So the other thing I want to look at are human-machine interfaces and take a look at what we have and what we're working with. So some of these devices you probably recognize pretty well. There's also the Kinect, there's voice, and there's something called gaze tracking, which you probably many of you are probably not as familiar with. And gaze tracking is essentially getting a sense of where you are looking. Okay? And then you have mind control. Right? These are not the droids you're looking for. So this is what we're dealing with. Most of these are, or at least 5 of these are something that we're using right now, and then 2 of them, gaze tracking and mind control, not quite yet something that we're using yet to control machines, at least not widely. These are my predictions on future hardware trends, and so I'm looking at hardware because hardware is deeply connected with how we write code, right? Currently, we primarily use a mouse and a keyboard, And what's interesting, though, these are my predictions, right, is as we move forward, if you'll read ahead, you say that, or I say, Mark says in 25 years, the mouse is dead. We won't be using a mouse anymore, right? It's kind of like, I feel like I'm going back in time to 1970 telling the people that are flipping the switches on the punch cards, I'm going to say those switches are going to be dead in a few years. You won't be using those anymore. And they're being like, no, we love our switches. Well, I say the mouse is dead in 25 years. Let me show you what's happening before this. In the next 5 years, I predict that Kinect is going, and vision depth perception in general are going to become better, more adept at what they do. Right? The Kinect is the #1 fastest selling electronics device of all time ever. 10 million of them have been sold already, right? And so what's going to happen with Kinect? Well, I predict you're going to have more detailed skeleton data all the way up to including the fingers. So right now with the Kinect, you can tell where the palms are, but you can't tell where the fingers are, what position the fingers are. But what does it take to get there? It takes a higher power processor on board the Kinect and a higher resolution camera. Those things are trivial when you're selling 10 million units, right? The next version is undoubtedly going to have higher definition, so it's going to have higher res camera, smarter, and we'll be able to tell where the fingers are. In addition to that, you'll get facial recognition. Well, you already kind of have facial recognition, but you have a better facial recognition, and when I say facial recognition, I also mean facial expression recognition. And coupled with that is emotional recognition. Now, all of these things, oh, and one more thing that you get too, that you're going to get with this, if you get a high-res camera that's high-res enough and onboard intelligence that's smart enough, you can get gaze tracking essentially for free. So you can tell where I'm looking to some degree of precision, right? And as we move forward in the future, that degree of precision will be more and more precise, right? So what's cool about this is that these things provide context. Right? If I know where the users are looking and they say something to me and I hear it, like delete that, I know what that is because I know where they're looking. Right? So that provides context. So in 25 years, I see the mouse is dead. The keyboard, in a last desperate attempt to stay, in your hands, goes custom. So we're able to say, hey, you know what? I want a custom keyboard with these buttons on it. I want a button that says declare. I want a button that says refactor. I want a button that says go. Okay, I want those buttons. And so we're able to create our own custom keyboards as well that allow us to be more efficient. Then comes the cool stuff. Wi-Fi enabled brain implants, right? Awesome. So already at Duke University, they've got monkeys with brain implants that are controlling robot arms with precision, simply with their thoughts, right? The brain implant goes right up into the top of the brain and it senses the synaptic connections related to muscle control, and so all the monkey has to do is think, and actually it starts with the monkey actually moving a joystick, and then the monkey learns over time he actually doesn't have to need to move his arm, he just thinks about moving his arm, right? So the first step in the brain implants, well, there's a couple things. One is you need it to be Wi-Fi enabled. Right? We can't walk around with cords coming out of our heads, right? That's going to be a little ridiculous, right? So we need to be Wi-Fi enabled. There needs to be onboard power, etc. But the first step that we already have is control. The next step, and this is where things get really, really interesting. The next step is tactile feedback. I reach out and I can actually feel something against my fingers, right? So I have that tactile feedback. And then the next step after that is augmented reality, where instead of wearing glasses, I'm simply, intercepting in the optical cord and just projecting imagery right in. At that point, we can create anything. Any world you want is essentially doable. It's like the holodeck on Star Trek, right? So Wi-Fi enabled brain implants. When that happens, the mouse is definitely dead, the keyboard is dead, the pad is dead. Everything as we know it is dead in the next 100 years. Okay? But and I guess we might be as well, unless another plan I'm working on, but it's a different slide, a different session on life extension, but we'll work on that. So, all right, so there's a picture of a custom keyboard, and there's a picture of a mouse that's not a mouse that's going to, well, that mouse is probably dead as well, but it's got the brain implant there. So, all right, so with that, let's go look at, because I promised you, I said this is going to be near future. Let's look at what kinds of things the near future IDE might hold. So with that big long-term picture, we'll look at that. So One of the things that I think is interesting are code snippets in Visual Studio, and my prediction is that code snippets may become more generalized and kind of something that you can combine together. So the idea is it's kind of like if you're playing a video game where you press one key for a kick and another one for a punch, and you do them both together. You can do a kick-punch combination. The same thing I see happening with code snippets. So the idea is here and take a look. You can see down at the bottom here the keys that I press here. Let's verify that that's actually working here. Maybe this is disabled. Let's turn that back on so you can see whatever keys I press. There you go. All right. So in the bottom you see the keys that I pressed. So if we type in C, for example. Whoops. Let's try it again. All right. Oh, let me switch up because of time. Let me switch over. I'm going to go over into. I'm going to come over here, and we'll do this over here instead. So we'll go over in C#. So we'll type in C, and then we'll type in employee, like that. And then we'll come down in here. Let's say we want to create a new property of type I for integer. So we'll type in P for property, and then I for integer. We'll combine them like that, and we'll call this like age, for example. That sort of thing. So with a few keystrokes, we get a lot more code. And the same thing, the essence of this is that the same keystrokes work regardless of what language you're in, right? So if I'm over here in VB and I type in those same keystrokes, I get essentially the same code, but it works in VB. Likewise, if I'm here and I type in VB-specific code, for example, I come in and I say if, and I say value equals 0, and I type in OR, which is a VB construct, right? I hit the space bar, it would convert it into a C# piece for me. Like that. Or if I typed in and hit the space bar, you do that. So that's a possibility of, right, what happens. The cool thing about that is if you're over in VB and you type in internal, you'll get friend or something like that. Right? What's neat about this is it decouples the language barriers, these natural language barriers, so you can transition from one language to another. It's a possibility of something that you might see. The other thing is this combination thing that I talk about, right? Instead of just typing in P or PROP and hitting the tab key for prop, and then going and filling out what the type is, you just specify a mnemonic for the type. So P followed by a B for Boolean would give you a property of type Boolean like that. Is fired. Okay? All right. The other thing that I see coming in the IDEs from the future is a deeper understanding of the code, especially when it comes time to do things like to do a declaration based on what you've done, consume first declaration. So here we have an example of a lot of code that doesn't compile. And what we can do is we can come up here, for example, and we can hit a key and choose, for example, declare class, and then what would happen is the class would be built based on everything it sees inside of here. Right? So where we had release date is equal to date time now, up here we have a property called release date, right there. Okay? That sort of thing all the way through. So it sees everywhere it's used. Same thing down here. We come down here, declare class called superhero, like that, and there's the pieces for superhero. Come down here, element.kryptonite, do the same thing, declare that as an enum, and it just grabs all the pieces. It can see kryptonite, it can see hydrogen, all the uses of it all the way through. Right? So it's a deeper scanning, a deeper understanding of the code. So I expect that to come up in the next 5 years. Right? I expect that sort of thing for you to see that. Okay? Let's go over here. Modeless flat UI. So, for example, if we come in here and we want to do a reorder parameters on this, what usually happens is we see a dialog that does this. Now, the problem with these dialogues is they're a little slower to work with, right? They change your perspective of the code, okay? In fact, they force you to adopt a new user model for this. Instead of looking at parameters in the code, I'm now seeing them in a list. I see I've got to click buttons to move them up and down, that sort of thing. My prediction is that in the future, when you want to do a reorder parameters, it will look something like this, where we simply just move the parameters right through the code like this, and then we hit enter to apply that. Extract method, let's take a look at this. If I were to select this, the same thing. If we come in here and we go in extract method, we get a dialog that looks like this. My prediction is that in the future, these will go away, and what will happen instead is you'll see something that might look like this at first. Okay? And what this is doing is it's showing you the flow of local variables coming in, right? So you get this kind of preview hint coming in and out, right? And you can see what that impact is, and also a preview of the call you can see there. If we were to change the selection, for example, to there and do an extract method, okay, or maybe to here and do an extract method, you can see things are changing, right? Instead of having ref parameters, I've now selected I've got output parameters. What's nice about this is it shows you what the preview is going to look like, and then when you hit it, when you hit enter on it to accept it and decide where you want to put it, you're right in there ready to change the name of the method, whatever it's going to be, and it may even be a good name for the method, right? I also predict that naming the methods will be, there'll be less of this typing in for methods because of smarter heuristics and perhaps even machine learning coming in to get a sense of what do you do when you extract a method that looks like this? What do you call it? And coming up with a good name. Okay? So, flatter UI. The next thing that I predict is a richer document experience. So for example, you can put bitmaps in your source code like this, right? Just stick the bitmap inside of there. Or for example, you might put a flowchart inside of your code. You might, right? I personally get a little nervous because I want to make sure my flowchart's always in sync. I'd rather have the flowchart dynamically generated, right? So it's not like a comment and it doesn't get out of sync. That's what I want, and I'm probably going to get that. But it's something that you can do, right? Or that we should be able to do in the future. Okay? Color swatches, right? Things that are hard to see should become easier to see. So here, for example, I have color, 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 and not only can I see the color swatch, see the pink right there or the purple, I can click on it and I can change the color dynamically right there and click OK, and then it's changed the code for me and the swatch will update. There you go, right there. Updates like that. And that should work not only in C#, but VB, XAML, and CSS files, right? We want to be able to see the things that are hard to see. And that's what, that's another thing that I predict you'll see in the IDE from the future. So there, for example, is a CSS with the same kinds of color swatches in it. Let's see, what else do I have? Oh, and unit tests also. Has my test failed or not? The little icon next to it, choose Run Test. I've got an exception in it, so we should see it fail. Testing started down here. There we go. You can see that it failed, right? Updating right there. Make a comment in it, comment that out, and let's run it again. There you go, and it's passed now, right? So that kind of thing, right? Putting helpful things right in there next to the code so I don't have to move out. All right, and we talked about, this custom keyboard idea. This next demo is something that I think is kind of interesting. Let's see here. First, I'll show you the interface, and let's break out my new keyboard and work on this file right here. So this is my keyboard. If I want to move up and down, I just strum up, strum down. If I want to create a new class, like that. If I want an uppercase letter, do that. Lowercase down here. That. Bus. And let's create inside there a new timer. Like that. And let's do some, let's see what we can do on this here. Hold on, let's not do that. Let's go back a second. There we go. All right. So let's encapsulate an event of the timer. So the timer's got an elapse event. Let's actually bring that out into bus and put it right there, like that. Let's jump back to where we were. Let's come back up and again. Let's encapsulate a property of this, the enabled property. We bring that up out into bus as well. So now we've got an enabled property out there as well. And we can jump back. Like that. So this is actually something that I really like working with. And the reason I do is because the navigation on this is actually more intuitive for me than it is on a keyboard. And I'll show you why. To navigate up and down, I just do up and down like this. If I want to go left or right, I hold down the green fret and just hit the strum in one of the two directions, right? If I want to go camel case, let's get over here. If I want to go between the camel case navigation, I come down one. So this is left and right. One is camel case, so it's getting bigger as I move down. So see what I can do? I can come in here like this and just put the caret right between the two, okay, with the uppercase letters. If I want to go word to word, I come down one more. So now I can go word to word, like this. If I want to select something, I hold down the blue key while I move. So I can select, for example, like this, right? If I want to select things logically, let's come down in here. And I can use the orange one, and strumming up is going to increase the selection by logical blocks, like that. Strumming down brings it the other way, right? Like that. What did you say?
So we are enabling musicians to code?
Yes, this enables musicians to code. Yes. You get a free t-shirt. Come up to me afterwards and I'll give you a t-shirt for helping me out with a joke. So with that, I will stop and I will say thank you very much and enjoy the conference.